Hey, how are you, everyone? I'm glad you're here again, back to our image processing workshop. This is our third edition, I think. Yeah, maybe. I see a lot of you guys are joining us. I would like to know if you were able to join us on our past editions. Oh my God, it's 3 a.m. in the morning for some people here. That's really cool. Um, I don't know if you already registered on the MLH link, but I will share it with you. Oh, I just shared it on Twitch. I'll need to share again in YouTube and Facebook. Just give me a second. Yeah, there is the link. So if you haven't checked in with your MLH account and you're watching this, it's okay, but help us checking in. Um, so, how are you? What do you expect from this workshop with for this session? What do you think we're going to do now? And if you had joined us before, what you learned, what you remember we saw on our last session, share with us, please. That's like a face. No, we're not going to learn OpenCV. We are going to use the Matlab tool to process some images. On our last session, we learned how to use linear gradient to detect borders on images. Uh, Now we are going to use three more process to do that. They are like much quicker, but the results are kind of different. When we're done with that, then we are going to process the text in an image, so we can get the every single letter from full text. So how we do that, it's what we're going to learn in this session. Um, yes, MATLAB, it's a tool we're going to use, but it's not the only tool you can use. I mean, you can do this with Python, with JavaScript, or whatever other language you know. I am only going to use MATLAB because it has some pre-built functions that make this easy to share with you now. But again, feel free to use whatever other programming language or tool you want. If again, if you're doing Python, it's okay, and I will be very glad if you share your code to the rest of the group, so everybody can see what you've done. Uh, I will keep reading some more comments, and then we'll start. 5 hours is really, really low for CTF. Oh, I see you, Wei, here. How are you, Wei? Hi, I'm very glad to see you here. Oh, Pollard, you didn't know, but Wei doesn't rest at all. He's just awake 24 hours a day. I have image processing good in Solbus. We use Matlab, and not very happy face. Again, you can use whatever tool you want. It's up to you, and it's okay. Okay, it's yeah. To be honest, here it's MATLAB, the language with one base. Yes, and MATLAB isn't that of a programming language to be full technically uh, fair, but you can see strange things like this. It's not a zero base index language, it's one base index language. But again, it's just a tool. Don't be too hard on the language. Don't be too hard on. Let's not use Matlab. Let's use Python. You can use Go or whatever language you want. Don't get picky on that. Focus on what are we doing, not how are we doing it, right? So I see everybody here, it's ready for start. So I'm going to start sharing my screen, and I would like some feedback about if you see it or not. You see it now? No, sorry. Yeah, now you have to see my screen. I will put this full screen so you can see it better. No, okay. You're supposed to see my screen now. I'm hoping you're doing. Yeah, it's visible now. Thanks a lot. Okay, so a little recap uh, of what we did before. We took a flower, an image of a flower, and we saved it in an image variable, right? Um, we show the original image, and oh no, this is not a recap. This is what are we going to do this session. The recap is here on this other file. Sorry for that. It's happening. Remember, MATLAB, it's really, really slow. This is an image of me. Remember that we have to save our image in a variable, then show our original image, and make it to grayscale. This function that it's built in MATLAB uh, translates RGB format to grayscale format and save it in an F variable. Then we show the F variable, and this will be our image. But why are we doing this? Remember, we want to take advantage of what we are going to do. It's take advantage of the grayscale to just detect the borders on the image. We don't care about the colors, the hue, or whatever other things in the image. So we can translate the RGB that let us the colors to a grayscale image, so it's less information we have to process. And with this double, we're just ensuring that the data in the metrics here, it's positive and negative numbers, right? Uh, then we get the size, like how many rows and how many columns we get in our F image, which is the grayscale. And we go like every single value from the rows and every single value for columns, checking our pixels. So we take a pixel and take a look at this. As Wade told us before, this language, it's not zero indexed, so we start at the number one number. So our first value, it's stored at the index one, and here we are starting at the second value because we want to compare the next pixel and the previous pixel. So in this case, if we set this to one, when we are try to compare the previous pixel, there is no previous pixel, right? So we set this to two, and we take the second pixel on our image and compare the values from the next pixel and the previous pixel with the others. And we do this the same for every column. I mean, the pixels on the columns and the pixels on the rows. Sorry, I do this with my hands again. Um, and we store our values from x, which are the rows, and for y, which are the columns. That let us in an image like this, that we, for example, show the mesh in the x, an image with the horizontal borders really well defined, but in the vertical lines are not well defined. In the image show that are for the rows, we take this picture and we saw that the horizontal borders are well defined, but not the other ones. So how we fix this? We took at least the y and x vectors, and we join them. Oh, I just have a text from way, and you're now seeing my screen. I really apologize for that. Okay, I'm going to share my screen again. Okay, are you seeing my Matlab uh, screen now? Or I will take advantage of this mistake and I not yet. Okay, that's a problem. I don't know why. Give me a second. Okay, are you seeing it now? Please tell me that you're doing. Yes. Thanks a lot for your help, Wei. I'm going to take advantage of this and just read some comments. Okay. Using average RGB values. Uh, I think I don't get your question. Could you extend it more, please? Will we use a kernel and a computational for edge detection? Not this session, but we can do it. We totally can do it. Um, no, it's okay. That's all the comments. So back in MATLAB. Sorry, I will explain again so you can see it. This is our image. It's me, and we store our original image with the imread function in a ima value, right? So we display the original image, which is this, and as I was saying, we turn it into a grayscale because if we want to take borders with at least with linear gradient, we don't care about the colors. And we save it in an f function. And if we show it, it will turn like this. It doesn't seem like borders, right? It's just some points randomly. So how we do it, it's we take the information of the sizes of the columns and the rows from our grayscale image, and we go every column and every row, taking the second pixel in every time and comparing its value for the next and the previous pixels. As you will see here, we have our first for statement, and we set our original, sorry, our initial value here to 2 because again MATLAB it's one indexed a language in which we have no zero index value. All our values starts at the number one. So our first value is the first index number. And then inside that, another for statement to go the first every row and then every column, right? And we compare here the previous value to the no sorry the next value to the previous value, and we store that in the original value, right? And when we do that, we get full matrix of information that has the borders in the x or in the columns. And we can do the same for the rows, and we store the previous value and the next value and the previous value for every pixel in a y matrix or gy, which is the columns. If we show here with this mesh, let me see if I can rotate this. Okay, I think I cannot rotate it, but here you can see like very horizontal lines. Uh, this is this image. You have horizontal lines, which is are like the horizontal borders from the image, stores in the gx value. If we do the same with the gy, we have like okay, we have the other thing, which are the vertical lines. When we join them in a single matrix here, which is just called G, you can see we have a very good look for all the borders in the images. But again, this is just a recap. This is what we do in the previous session. This is a way we can do this with linear gradient. But there are more ways we can do this. Uh, for example, uh, here Polar B01D told us if we're going to use convolutional functions for edge detection. That's a very cool way, but the thing I prepared for this session is using some masks. These masks are called, here is the code, the Sobel and the Prewitt masks. And as you can see, this is like a very simple code, and we're going to build this from scratch. So how can we do that? Just let me prepare some things first, which a good practice when you're using Matlab, it's CLC, clear all for cleaning the workspace, and close all if you're using regular script for closing all the figures we can have. Uh, and that means what I just do, it's a section break. You can double percentage this and just hit enter, and that will break the file in another section. Then we have to store again our image in a variable, right? Just copy and paste that. It can be the same as this. And let's show im show just to verify everything's okay. And we can run this. We saw how our workspace here is clean now. And let's see if we get our image. Here is our image, right? Um, what we have to do next. Okay, when we apply a mask to an image, it means we don't necessarily have to process every single aspect in the image as we do before with the linear gradient, right? Here we we fully split our image in data. Here, Matlab has some very good pre-built built-in functions that help us do that. Um, just give me a second, and I'm configuring some things. Ooh, I will need a little break. Give me a second. I will put some music. Okay, sorry about that, but we are back. So I'm going to share my screen again. You're seeing it. Cool, cool. Okay. I just need to open our little file here. Okay, we show your image when you are really sure this is okay, right? And again, we don't care about the colors. So what we need to do now is to have our grayscale image. To do that, we are going to first use RGB to gray function and pass the image. I want you to notice something. If I run this, look at the values we have here. And then I'm going to do the double thing to the previous gray values. The output looks really similar. Okay, uh, let me expand. But there's a difference, and I will need some time to find it because everybody here looks like pretty similar. But there are some cases in which, okay, we have uh, negative values that we don't want. And with this, we ensure that doesn't happen to us. Okay. Okay. It seems that in this particular image, we don't have those values. Oh, there's a black. Yeah. It probably be at the very end here. No, once. Let's see. Okay, around here, this should be. No, okay. Don't worry. Just do this as a good practice to ensure uh, all the values in your matrix are positive, and we can reduce this in a single code here easily. And the next thing we have to do is again get the information for the rows and the columns. And to do that, we are going to use rows and columns. Rows and columns. And with the function size of the gray. For those that are that similar to Matlab, and this is your first time using the language between codes, um, here you will see that in some cases I use semicolons and in some cases I don't. If you use semicolons in MATLAB, you did you like hide the output of the operation. Here, for example, I use semicolons to don't display these metrics anymore. And if I take the semicolons of these operations, we will see the result of the rows and columns. And you can see it here. We can see row and columns, oh, rows and columns. And if I put the semicolon again and run the code again, same code, uh, you will see that we don't have it anymore. Uh, just a little fun fact there. But okay, how do we use the subble mask? To use the subble mask, we will need a matrix to perform a transformation here. Remember, MATLAB is short for Matrix Laboratory, so that's another reason I am using MATLAB. To do this, for example, in Python, you just need to use a library as NumPy. It's not that hard, but here we have it, and it's built-in, so why not? How we build a matrix here in MATLAB, we will do the S for matrix of subble, X for the X, like the X part, and we will have again a Y part. You remember we do this before for the linear gradient, and it's almost the same. But in this case, we are not going to perform a loop in our original matrix, which is the gray picture. Remember, if we display here again, just let me comment this. Have this in mind. Yes, or picture, I just, yeah. Or picture, it's an image that we can saw, right? Uh, but it is also an array of a matrix of information. And in this matrix, we have a lot of values. It's an 810 times 720 number length size, which are the rows and the columns. If we want to perform the mask on this matrix, which is our image, we will multiply the matrix or the original matrix for these matrices that we are creating now. And these metrics are already defined for mathematicians and people who, uh, yeah, who do research in this. You can type like Sobel metrics, and we are going to find uh, just a Sobel 3 times 3 matrix. And we can see this. It's the, for example, in Stack Overflow, we see this is the matrix we want. It's 0, 1, 2, right? Minus 1, 0, 1, minus 2, minus 1, 0. This is for the x and y uh, parameters, right? So this is not a thing I am like testing right now. This is a very well proved material. I'm going to copy and paste that. Oh, sorry. Oh. Okay, here we are. I'm going to take out the semicolon so you can see the matrix better displayed here. Both are 3 times 3 size matrix. And to do this for Prewit, it will be the same. We can Google Prewit matrix and we will get the matrices, right? So you can do it, or you can copy and paste mine. And I'm going to take out the semicolons so you can see it. Okay, that's cool. So what are we need to do now? I kind of lied before because I told you that we are not going to iterate for the matrix, but that wasn't true at all. We need to iterate, but what we do in the iteration, it will be different from what we do before with the gradient. Uh, so for y, which are the columns, and we start in 2, remember, because we want to take the pixel in the second position to compare with the previous one. If we start in 1, there will be no previous position to compare. And in these matrices, we want to take the second position here. And oh, I erase it, but I'm just going to print it again. Hmm. We want to take, we want to multiply this 114 times the matrix here, but it will take 3 times 3 slices of the big matrix we have to get a new little matrix with the information. So for y that starts in 2 and it ends in the length of row, Oh no, it's not length. I forgot that we already have the row. -1, again, because if we get to the really end, there will be no further position to compare. So we want to stop one little pixel before. Um, in Matlab, you have to close your for statements. For x, then starts in 2 and goes to columns -1, and And the thing we want to perform here for S, which is subtle, and for P, which is for pre-width, it's that we want a new matrix. Let's call it as result subtle in X, and we want it in the position of the columns X, and the rows. But remember, here are starting in the second position. We want this from the really beginning. So let's subtract one single value of this. And this is going to store the sum of, again, the sum of the gray image in the position first, the x -1, and 2x plus 1 y -1, 2y plus 1. And this multiplied by the first matrix of Sobel. In this case, we are in the x position, so Sx. Um, these are matrices, so this goes first. What does this dot mean here? Oh, this dot tell us that the multiplication, it's not going to be uh, matrix times matrix. Remember, Matlab, it's a metrics laboratory, so it's supposed to have, it's supposed to be prepared to multiply matrices, but we don't want here to multiply matrices. We want here to multiply just every single value from here to every single value from here, and taking these slices from the previous value in the gray image to the next value in the gray image on X and on Y, translate to take like this corner, right? So if we do this just one time, or resulting matrix, it's going to be the multiplication for this matrix here as X to this slice of the original matrix, which is from 114, 91, 77, 114, 125, 99, to this edge, which is 63. You can see it on the cursor. And if we keep doing this uh, for the entire loop, we will get the result smaller matrix containing the information of the borders. And the same for RS in Y. Remember, R result solved in Y. And the same we want to store in the first values, and the sum of the sum of S Y multiplied for the fraction of the original image, which is gray, from x minus 1 to x plus 1. A little notation that I may be not explaining here, it's what does double dot here means. It means, uh, again, I will take uh, a break here to explain that. Maybe you're not following me. We have gray, right? And we know gray, it's all these matrix. But if we just want to show a little portion of gray, we will have to tell what values of gray we want. The first values are the rows, and the seconds the columns. So if we just say, right, gray 1 plus 1, the output will be 140, right? But if we say 1, 2 dots, 2, it will be like telling Matlab from gray, take from the first to the second rows and the first column. So if we run this again, you will see that we have the first and the second rows, but just from the first column. But we can say from the first 5 columns. Okay, with the first 5 columns, the first 2 rows. And what are we doing here is take previous column and next column, the previous row and the next row, and display it. And it will be like doing this. And we get a 3 times 3 sized matrix, which we multiply to Sx. The answer will be this one. It makes sense, right? If we multiply 114 times minus 1, we will get minus 114. If we multiply all the middle column here, which is 0 times whatever, we will get 0, 1 times 77, it's 77, etc., etc. We want to do these for every single slides of 3 times 3 matrices in the original. So remember these values. Well, you don't have to remember. I'll just leave it here. And we will show that, oh, well, first let's end with this example, and then we can show whatever. Plus 1. As you see, it's very similar, and we will have the RSX and RSY values. I am just going to run this one time. Row -1, and I'm going to break here. Here you can take breaks from the execution. And for example, let's run this. Oh, my bad. The break it's supposed to be here. Let's just stop the program and run it again. The output it's just a single number because remember we are not just multiplying the result here times the SX matrix, we're summing that. And what does sum does? We can always here in a command window, it's like common, uh, yeah, it's like a normal toolkit. You can type help and sum, and you will get the output. So let me expand this. Sum of elements, and in this case, we are summing the result of this operation, which is a matrix, and is the sum of the elements of the vector. If we sum all the elements that we had in the previous vector, in the previous matrix that we show, this one, the result is 199 negative. Maybe in numbers that doesn't mean a lot, but in the real world, when we display this, we will see that that shows the borders of the image we want. Let's take out the break and let's run this and let's show im show rsx and rxy. And let's make this. Oh my god, I forgot to put the semicolons. 1 second, or this is going to break. Yeah, here we are. Okay, that's a problem. Index in position 2 exceed the array bounds. What we do, what maybe we can do wrong. Okay, I'm reading the code, and I don't think we did anything wrong. Mm, but let's ensure that. Okay, where did we get the 720? Okay, I don't get where are we getting this. I mean, the code seems good for me. But let me just not display the image show, just display the RSX and RSY values. Okay, now we don't need to display this or this. Row code size, row code size. Okay. We can do another thing. I wanted to show you this in separated things, but we can end this just displaying the result sub. How do we get this result sub? With the sum of these ones, right? But it's a little bit more complicated than that. Nah, not for me. It is not isn't that complicated. It's the same procedure. We want to store in our first values, which is 101. The square, sorry, the square of the SRX matrix, sorry, RSX matrix, and the SRY or RSY matrix. Remember, we have some specific values which we can find in the same position that we are trying to store them, which are these ones. And at last, we do this. Once this is stored, I think we can, yeah, we can display this. Okay. Wait, just give me a cool tip. Thanks. Wait, you're saving my life. Yeah, sorry about that. It also gets me from the attention. Um, to recover the attention, I'm just going to read some comments. Oh, I didn't hide this. Okay, we don't have any comments for now, but that just means we can continue. Yep, we can display the result subtle. So result subtle, it's the index in what? Give me a second. Okay, yeah, I think I know what's happening. Remember, I told you what? I just turned this on focus mode. What the fuck? It's supposed to be in focus. Sorry, I don't know what's so important that they are trying to reach me. Okay, don't worry. Uh, I know what we're messing up here, and it is, I told you the first position it's for rows, and the second position it's for columns, right? The previous error that we were seeing was that we can not pass 720, uh, but we were doing it apparently, and that's why we are confusing these definitions here. The first it's for x, which are the rows, and the second it's for y, which are the columns. So if we run this again, we will have no error. What? It's supposed to have no error. Okay, let's comment this. Just give me a second. That's it's supposed to not give an error here at least. Yeah, we're good. So we can do what we want to do. That it's in show the result sub of x and in show the result sub of y. We can do that. Come on, come on, come on. Matlab it's sometimes okay. Cool. You can see like vertical lines here, right? Even this noise we have here means that this is our subtle from X, and this noise it's horizontal. This it's from Y. We have now our images in X and Y, and same with the linear gradient. What we have to do is join them in a single value, which is result subtle. But we have a mistake before. What's that? Let's recap, and you can type on the comments if you find it before me. But what we are going to do is take the square of the every single value of the rs and add it to the square of every single value in rsy, and then uh, the square will be the result. That means what we want to do, it's just like a times it's equal to b plus c squared. But the problem, if I can find it, let's see what the output says. Index in position 2 is invalid. Index in position 2 is invalid. What's the position 2? We have the rs, and we have our rs here, here. Okay, maybe it was something about the indentation. No, it wasn't. Square srx. Anyone on the chat? Maybe you can attend the call. Okay, thanks you for your comprehension, but there are no calling anymore, so we can continue. Thanks a lot. I love you guys. Now I want some help here. It's supposed to be okay. I mean, we're doing these. No, if we apply the squared here, there we don't need uh, 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 to be squared here. Rs in this position, first position, second position, it's squared x minus 1, y minus 1, rs y, rs x. I can try to do something like this just to make sure it's not confusing anything. Okay. Hmm. Oh, I'm I'm not sure of why this has happened. I mean, index in position 2 doesn't mean anything. Index in position 2. We can try to do this separated. I mean, like, uh, mm, this way, and then just apply square 2. Okay, so maybe the problem is in RSY. Yeah, if we change positions here. Yeah, the problem is in RSY. Uh, I don't know why I type a 2 here. Yeah, that was all the problem. Oh my god. What a problem. Okay, and we can delete the X here. And finally, we get our subtle border detected image, which is this one. Come on, Matlab. Display it. It looks weird, right? So we can do a little trick to configure the borders. For that, we need to multiply the result first to convert to int 8, and then we can multiply again. Remember, the dot is, it means every single value here in the matrix is going to be multiplied by 5. So let's run it again. Wait, you don't recognize. Oh, it's not unit, it's unit. Oh my god, I'm terrible today with the typing. I'm way better. Uh, I'm pretty proud of this. And just to do this quick, the process is going to be very similar for Prawit. Prawit, yeah, it's not going to be similar. I mean, it's going to be the same. So we can come and see, come and B, paste this. We just need to rename, and instead of a subble, RP for private, private, um, and instead of SX, PX, and instead of SY, PY. And then we can write this properly. RP squared of RPX in the positions, in the original positions, elevated, and RPY in the original positions, elevated. And we can show this RP and see what's the result. Okay, this is the first one. So this is Sobol, and this is the second. So this is for Prewit. There are slightly differences we can appreciate. Uh, for example, here with the same processing, I see more detail in the lifts at the back. Here, like the veins we have here, uh, I don't know. I don't know what do I like most, this, if this one or this one, but we can compare, and we can even add a little code here now that we already know how to do linear gradient, and call it gradient in X, gradient in Y, gradient in total, and do what we have done before, uh, and just compare the values. Oh, I need to add this. Just a second. Remember, it's x minus 1 and y minus 1. And replicate this here and here. And we can turn the gray function x minus 1, x, y minus 1. Sorry, I think here it's plus 1. And the minus, yeah, it's difference minus gray, uh, x y minus 1 divided by 2. And the opposite from here, it will be gray x plus 1 in the first minus gray x minus 1 in the first divided by 2. And for joining this, we're going to again square it. It's almost the same. I mean, gx in the first position elevated plus gy in the first position elevated, and with this we can now show just the g. Yeah, it's supposed to be the same. Cool. I'm going to change to output line mode so we can appreciate. Here we have our gradient with linear gradient, sorry, our border detection with our linear gradient. Here we have our border detection with the subtle mask, and here we have our border detection with the pre-width mask. What do we get from this? Then you can adjust, for example, instead of 5, let's try to run this with 3. Let's see what happened. Oh, and let's try to increase them with 8. Let's go with 10. Okay, we have more detail, but not the same as we saw with private ensemble, sorry. But yeah, okay. A little recap of what we do. Um, we now have to do border detection, and we do it in 3 different forms. The previous session, we take the entire session explaining how to do it with linear gradient. And in this session, we do it with 2 different forms, prewind and subtle mask. As you saw, the process is really similar, not only with prewind and subtle, but with linear gradient. And it will be almost the same with Laplace transform and with convolutional, and there are many other forms that you be able to do this. It doesn't matter the language, it doesn't matter that it's Matlab, it doesn't matter that it's Python with NumPy or with pandas or whatever other language you want or library. The thing here is that now we explain the concept of how we're doing this, which is re- re- going pixel by pixel, um, verifying the information from the previous and the next one from a horizontal and a vertical way. So we store these in 2 different matrices, and then join them together. So that's why we are able to recognize, for example, if we are going to try recognizing the borders in my image right now. You will see for the vertical ones, these lines very well describe it. But in the horizontal, you won't see it at all. The combination of the two forms, it's the way to do this. In our next section, I will give you a little pre pre a spoiler of that. Sorry, um, we have letter processing, right? Now that we have how to recognize borders, we can try to recognize patterns in the images. The first thing and the most easy thing we can do now is to recognize letters. I have a file here called patrones, which it's just a Spanish word for patterns. And I just need to upload it here. Give me a second. It's in my downloads. Yeah, patron. And now it's uploading. Cool. You can see it. This is the original image. Ooh, it's very blurry. I don't think you can see it very well. Okay, so here you have to believe me. These are the letters of the alphabet, right? So this is A, this is B, C, D, E, F, etc., etc., etc. These are capital letters, and these are not capital letters. Um if we want to recognize the patterns in the image, first we need to process it to do it easy for us. So in this example, the the image it's with the white background and the letters are white. We need to change that. How we do that with the grayscale? Okay, I'm not going to take more time explaining this because this is what we are going to see on our next section, which is on Friday. But I can run the code and you will see what we expect. Take your attention here. Oh, oh, we have Sita, but that's a problem because we were okay. I need to uncomment this. Just I'll run it again. A B C D E F G H. All the letters we have in on original image is it's cool, and we get eventually to the Sita. And that's the end of the program. We're going to learn how to do this on our next section. If you have any questions this far about how to recognize the borders in an image, you can um you can put it on the comment. I will be here. I don't know, some minutes. But if you don't, you can go home, try to do this on your favorite program language, and that will be it. I hope to see you soon in Friday, which will be our next section. And as I show you in that session, we will detect not just borders, so patterns in our images, so we can extract, for example, here the letters from image. This is really cool if you think about it, because if you, for example, are working on some text recognition system, this practically solves all the problem. The next step will be train a neuron, talking about, for example, machine learning, to predict text uh, about other images. So we can take the information here in this image, train a neuron, and then pass another image with a similar font, and the neuron will tell us what the second image says without reading it, like translating an image to a text. And that's the process. And I just think it's really cool. So it was a pleasure, people, to have you here. I won't take more of your time. Uh, it's just not a goodbye, it's just a see you later.